For this last video in graph transformations, we're going to combine all of the components together and look at how the changes impact a parent graph. Let's start with x squared as our base graph. Looking at this line below, I can see that I'm going to be adding 1 inside the parentheses. Anything that's added or subtracted in the parentheses moves the graph to the left or the right in the opposite direction we would expect. So a +1 is going to move us to the left by 1. Anything outside the parentheses moves the function up and down in the way that we would expect. So a -3 is going to shift the graph down. So it looks like the new vertex has shifted over to the left by 1 to -1 and down to -3. Looking at the absolute value of graph, we also have 0, 0 sort of as our reference point. This graph is going to be shifted to the right by 1 and up by 4. Our new corner here is 1, 4. For the graph of x third, it looks like this. In this graph, we are inside the parentheses, the -2 is going to shift to the right by 2 and then down by 1. But that 1/5 on the outside, anything outside is going to impact the graph vertically, and the 1/5 is going to shrink the graph vertically or compress. So we can see that our new reference point here is 2, -1 as we expected. That's our vertical and horizontal shifting. But then the impact of this compression is that this graph is growing not as rapidly as the original parent graph. It's growing at 1/5 the rate. For the square root of x graph here, the +2 under the radical is going to move us to the left by 2. The +2 will move up 2, and then the negative is going to reflect it vertically. So let's see. Here's our new reference point. Left 2 and up 2, but you see how the graph is flipped upside down? That's because we reflected it. After we move to our new reference point, then we reflect it down vertically, and so it's facing this direction. Now we'll go in the opposite direction by having a set of directions, and we're going to write down what the function looks like. For the first example, we're going to start with a base graph of square root of x. And for our new graph, g, we want to reflect the original over the x-axis. So that means we're going to put a negative sign in front of the f of x. And we're going to stretch this by a factor of 2. Horizontal stretches happen inside the function, so we'll put a 2 inside the parentheses. So this is going to end up being negative square root of 2x. For example B, we're starting with the base graph of 1 over x. Our new function is going to be taking the original, vertically stretching it by a factor of 8, so that'll be 8 multiplied on the outside. And then we're shifting to the right by 4 units. That means that we will subtract 4 on the inside, and then up 2, that's a +2. So let's see, I'm going to have x minus 4 in the denominator. There will be an 8 multiplied on the outside, and then a +2. We could simplify this to have that 8 multiply into the numerator here. So this is our new function. For example C, we're starting with x squared as our base graph. And for our new graph, our new function, we want to compress by a factor of 3. That means we want to compress vertically. So vertical changes happen outside of the function. So I'm going to multiply by a 1/3. Then we're going to shift to the left by 4 units. That'll be x plus 4, and then down 3 units, -3. Let's see, I've got a 1/3. I'll have x plus 4, and then squared, -3.